Everyone, my name is Braff, and in this video I'll be demonstrating TimeIndexModulo. This is the second module that we've been developing at Never Engine Labs together with Christian Vogel and Gustav Scholder. But before that, I need to mention some significant changes that we've made to the first module, TimeIndexGroove, since the last video I published a couple of weeks ago. So first of all, the TimeIndexGroove is now using much less CPU, and that's really good news. So here in detail, maybe as you can see, there's no longer two patterns to morph between. Before, we were morphing between two warpings of a time index that were given by two arrays, pattern A and pattern B. Instead, it now is morphing between the straight and the warped ramp, and so you only need to specify one pattern here. This pattern can be specified in three different modes. There's the durations mode and the Euclidean mode that we already had before, and now there's a third mode called binary mode, where you actually will enter the pattern in a step sequencer-like form, using only ones and zeros. So here my pattern 211 would be 2 1 1 in a binary form. You can select the desired mode by typing here which mode you want. So for binary, as you see, you type 101. You will type 21 if you want it to be durations mode, and you type 2/3 if you want it to be in Euclidean mode. Another novelty is that you can have now the module output here, groove metadata, which is actually a set of variables useful to share with other modules. So you will need to choose a suffix here for those variables to make them unique and then pertaining to only their actual instance of the module. In case you are using many time index grooves in one single sound design, this can be helpful. And you can here choose whether or not these variables will show in the VCS. And here, last but not least, we've added an invert mode, where the resulting warping will be the one that would straighten the normal mode warped ramp. So in other words, you have a warping transforming a straight division into a given pattern. Invert mode will change that pattern into straight divisions. So maybe let's have a quick look at this new time index groove in binary mode. Here it is. So here you can see that I have chosen to have the pattern array values as toggles here, as we're in binary mode. So like this, I can have a step sequencer-like interface. So here I'm changing the patterns so you can see in the oscilloscope the different warpings happening as I change the pattern. So note one thing is that zeros beginning the pattern are ignored. So the pattern will be read only from the first one. So yeah, maybe here you can see the groove metadata. One way you could think of tuplet size and absolute size here is as pulses and beats in Euclidean distribution. So here with my pattern, I'm having 3 pulses per 5 beats. The only difference is that I've been free to choose the pulses distribution. So it's not really an Euclidean distribution, is whatever distribution I choose. So here, this pattern was represented by this warping here, is actually 6 pulses per 7 beats, etc. So this is the the binary mode. And maybe one word about the groove balance variable. Groove balance gives you an indication of whether the groove is pushing or laid back, and as well as it gives also the amount of it. So pushing grooves will have a positive groove balance, like this one here, and negative grooves will be the laid back one. So laid back grooves have a negative groove balance value. So that's it. Let's now look in detail at our second module, the time index modulo. So with Christian Vogel and Gustav Scholder from the Never Engine Labs, we realized that if we wanted to do time index manipulations with all the fun modulations and algorithms allowed by the non-Euclidean rhythm theory, we needed a ramp frequency multiplier and divider that would integrate all the warpings enabled by time index groove here. So we could not simply read the warped ramp from a wavetable at different frequencies. This frequency scalar needed to behave algorithmically, and so here is time index modulo, a ramp frequency non-Euclidean scalar. Right, so this first signal here on the top signal is output time index groove, and this one here below is time index modulo. Time index groove has been set to pattern 211, so you can see now its characteristic warping. And so time index modulo has a numerator value and a denominator value. So if I change the denominator, I will divide the ramp. Right. And if I change the numerator value, I'm multiplying the ramp, maybe like this, right? So you can see here, changing the numerator value. My pattern being 211, let's divide here with a 3 denominator. And so as you can see, right, when I move the morph fader, you can see what it does to the actual ramp division or frequency multiplication here. So that's time index modulo. Of course, if I set it to a ratio like 2/3, it will work as well. If I do the morphing, you can see that the warping is always respected throughout the ramp integration. Right. So there's also something about time index modulo here. There's a gates mode. You can select output gates, and then what you have is gates with a duty cycle, of course. So you can adjust the duty cycle of your gate. And of course now, if I do the division, you have the 3 gates, and they will be warped as well, with the duty cycle remaining proportional. So that's to prevent masking of gates. So that gate mode is a pretty useful one. Also, you can trigger envelopes with it, or do all kinds of stuff, of course, with adjustable duty cycle and proportional duty cycle, which is actually very important. Maybe let's look at another example. So I'm reading with an original time index here a drum loop from Christian Vogel. So first I go through a TimeIndexModulo, and I slice the ramp in 8. Then this goes into a time index groove where I apply a warping following pattern 211, and then this goes into a TimeIndexModulo where I'm actually using 8 as a numerator this time to build back a full ramp made of the 8 slices being warped each. So each of the slices will be warped, and this last TimeIndexModulo is rebuilding the whole ramp. So that's how it sounds. So here you're just hearing the slices, if you wish. So I can change the numerator. So now every 4 microbeat, or every 5, and you can see the ramp divisions, slicing happening. Okay. So it resets when they meet again. So here I can morph. So you can see here, this is the output of the first TimeIndexModulo. This is each of the ramps being output by the first TimeIndexModulo are warped following a given pattern. And here there's a rebuild of the full ramp by integrating those warped slices. So I couldn't really even choose it to be 1 to 1. So here the warping is happening within each beat, and you can hear it in the change of pitch. Right. So it's really fun to play with. So here in this example, you can hear the warping in the change of pitches of the original sound file. Of course, you could do this time stretching without altering the pitch in Kima if you read from a spectral file, but I like somehow this pitch change happening because it really makes the warping hearable also in the pitch. So thank you everyone for watching. This was TimeIndexModulo. I hope you enjoyed the video.